Ben, this is Rachel, Laura and Nikki. The whole aim was to help them become more efficient with their energy, save money or reduce running costs all over, but they've recently been refurbished to make them more efficient anyway and become a smaller sort of setup store.
Well, light is made up of electromagnetic waves, infrared and ultraviolet. And there are lots of different types of lighting available. Fluorescent lights are one type. These prefer to be kept on, as if you turn them off, then it takes 5 hours worth of energy to turn them on again, so they aren't very energy efficient. Fluorescent lighting is also not suitable around food, as it has ultraviolet and infrared wave light, which makes food go off quicker, so it's not suitable in like co-op setting because it's around food. There's also LED lights. These don't give out ultra-red or ultraviolet light, so these are more suitable around food, which is better for like co-op. They're also more efficient as they give out 90% light and only 10% heat, so that's a lot better. And they last around 40,000 hours, whereas a standard light bulb would only last around 1,000 hours. Light is measured in lux, and the law states there should be a minimum of 300 lux in a working place. So we decided to take measurements at co-op to make sure that, just to test the readings, and the floor level should be 100 in a working place.
For a mini project, we were going to ask the store to turn off half the lights so that we could ask customers and do a questionnaire to see if they noticed anything different within the store. But because all the lights were run automatically, this was not possible. We also found it hard to refurbish, find problems in the store because of refurbishment and the new fittings they already had. And after carrying out our mini project, we found some anomalous readings which made us not really know if the answers were correct or not. However, we didn't have enough time to go down and redo this. So instead, for our mini project, we went round to the store because between the hours of 6 AM and 8 AM, they had half the lights on. So we took lux readings from this time, and then again when the store was fully open from 8 AM to 8 PM.
This is an energy audit map that tells us where energy is being used around the store. So the energy is being used here as you walk into the doors, and then even in the magazine rack they have light in. By the fridges and the freezers, they're all up here, down to the tills, and then even a little television screen here.
This is just information that co-op supplied us, showing how much energy they're using each period in a year. It shows, just by looking at the data, you can see that already they're below their energy consumption, which is great. However, it made us not know when to work around the store, so we decided lighting was the best place.
These are the results we got from the mini project. With the lux readings, it's between 6 AM and 8 AM, and only workers in restocking the shelves, so they only had like half the lights on, only needed to be seen. As you can see, it's all over the legal limit of 300 lux at like working level, so what you can read in that, all apart from at the entrance, but they can't restock the entrance. So these are the two anomalies, only 75 lux. I haven't actually got any explanation for that, just yeah. But then, as you can see, when the store was open between 8 AM and PM, all the lux readings come out at considerably a lot more than the legal limit. So therefore, the store couldn't be run the whole day on when it was just when just the workers were in. That does clearly seem to be not a very efficient way of running the store with all the lights on.
This information we got after we did the mini project, and we just used two types of how much it costs per unit, because we weren't able to find out how much they charge, and it just shows how much they have to pay each week just for the lighting, and it's quite a lot of amount of money really.
Okay, these are the lights and light readings which we found out from visiting the store. The lights, as we said before, are turned on 6 till 8 AM, and that's when the workers are restocking shelves, things like that. Then and they get turned on at 8 when the store opens fully. And as you can see, there's like different devices which use different wattages. These spotlights use 100 watts and there's 25 of those in store. So those spotlights use a lot of energy in the store. Here are some of the photos of the lighting. As you can see, there are the spotlights and some other lighting around. And you can see there's loads and loads in the store, which aren't probably all needed. And the magazine racks, there's also a lot of lighting in there, which we didn't really think was necessary. The wine racks have a lot of refrigeration and lighting, and so do the fridges and freezers.
This is just a graph showing the performance of Co-op itself. Where, we said they're below their target, so we're trying to save them more money than they need, really, because they are best in the county for saving energy as it is. As you can see, there's a few places on the actual graph when they come close to actually being on target. Those were the areas we were kind of looking to try and, well, lower so it's on par with everything else. This is the one over the year. As you can see, the energy usage is mounting up as the year, and still after 12 months they still come considerably below where they're meant to be.
The curve we're currently using T8 30i 56 watt bulbs. They are energy efficient lights, however there is a more efficient light which could have been used when they refurbished, which is a T5 24 watt. These are being used in stores that are being refitted currently. The Kirk have already looked at changing their lighting to LED lights, yet the barrier of fitting these lights is that it will take 10 to 11 years to pay back the cost of the fitting lights. To change the light fittings, the Kirk Energy team would 3 to 5 years payback time. This information was taken from the Energy Saving Trust website, which told us that the cost for installing a solar electricity system works on an average between £8,000 and £14,000, but that depends on its size and the type of panel you have. In general, the more electricity the system can generate, the more it costs, but the more it can save. The solar tiles can cost more than conventional panels, because panels built into the roof are more expensive than those that sit on top. But if you need a major roof repair, PV tiles can offset the cost of roof tiles. The savings can be considerable, almost 1 tonne of CO2 and around £200 of your electricity bill. This is how, go back just one slide. This is how much, if we got solar panels from a co-op, we worked out that a 210 watt solar panel would cost £771.47, and for the co-op to meet that annual target they would need 667 of these panels. We worked out what they would currently be spending, because we didn't know this, so we worked on an average of 8 pence. And then we worked out that it would cost 12 and a half years to pay back. So this is more than the LED lights, but their savings would be £306,892.80.
And this is just some photos of us when we first went down to the store and met Dan and worked out where they were using energy within the store.
Brilliant, thank you. Now, unfortunately, Dan couldn't be here today, so we've got Neil standing in.
Yes. There's one thing that's obviously come up, and given that the whole store's been redesigned, and actually looked at using any natural lighting there with sun tubes or redesigning the store to actually take advantage of.
That's the whole reason why we looked at the lighting, because they made the store smaller and everything to make it more efficient, but they didn't take into account the lighting. So where they have got the lights positioned is for where all the old aisles were set out, but they haven't actually looked into it at all. So there's yeah, it's not a lot. That's why we were looking at LED lighting, but it would be quite expensive to change